Hey guys, Stat 1150 Midterm Study Guide. What I'm going to do, I've uploaded on my MATLAB a study guide. You can do it if you want. I highly encourage you. It's highly recommended that you work through the study guide. It's going to be a lot like your midterm, so it's going to be an excellent resource. Students all the time ask me for study guides for midterm and final. I really don't understand it because everything that I do on the midterm is going to have been covered someplace previously in the class. But I guess it does kind of serve to comprehensively just put everything together and speak it through. So what you're going to need, I demonstrate some of the stuff using R, some of the techniques, but for the exam we'll use our calculator. And you'll need to log onto my MATLAB, and I'll show you the assignment that I've put up to accomplish a midterm study guide for Stat 1150. All right, that was very, very, very formal. Let's go do it. So this is being put up for my summer 2016 Stat class. So if you're taking this class in a later term, just keep that in mind. But nevertheless, there will be a document here, midterm study guide for practice only. So let's go do that. And let me grab my calculator. So 36 questions. So it's going to take a while to run through this. I'm going to miss a couple of questions on purpose. See if you can figure out where I miss, and then at the end we'll get a grade and we'll go back and see what we do. Get done. You get 2 attempts per question on your exam. Now, on your homework assignment, you get infinite number, well, as long as time will allow. So, okay, anyway, the histogram shows that we have 92 community college students, the number of televisions in the homes. Complete A through E below. According to the histogram, how many homes do not have a television? Well, it looks like above 0. If you look at the legend over here, it looks like that there's just 1. How many televisions are in the home that have the most televisions? Well, guys, that looks like it's about 8. Wow, you guys are going to be lucky if it's this easy. How many homes have 3 televisions? Well, it looks like we follow that up there. I'm going to go with, 27? How many homes have 6 or more televisions? So that would be... I think, well, let's enlarge this. That's going to help a little bit. So 6 or more looks like it comes over to 5, and then of course 2 more there. So I'm going to go with 7. Again, I will miss something later on, or maybe later on, just to see if you're on your toes. And also I want to show you an option that you have to go back. What proportion of homes have 6 or more? Well, if there's 7 that has 6 or more, then 7 out of the 92. So guys, if you'll take your calculator and take 7 divided by 92, your proportion would be 0.076. It tells you to type an integer. Or simplified fractions. So I'm just going to come down here and get this and do 7 over 92. Okay. Check answer. So we got 100 on that one. So let's go to the next one. When a distribution is skewed, the blank is the best measure of center, and the blank is used to measure variation. Well, guys, when you have a skewed distribution, it turns out that the median is the most stable measure of center, and the IQR is the best measure of variation. So mean and standard deviation go together, and medians and IQRs go together. So we're going to be right here. So. All right, let's go to the next problem. All right, so we've got a scatter plot. So the accompanying table gives the distance from a particular city to other cities given the time one randomly chosen commercial plane can make. So let's take a look at this. So we got some data there. So what I want to do is I want to put this in my calculator. So let me get out of the full screen. And for some reason or other, my presenter is going wacky. All right, so again, what I want to do first of all is I want to enter this data. So it's going to be, I'm going to clear out the data I've got in there. So I'll go clear enter, and then go up and I'll go clear enter again. So let's 1.129, 2.915, 3.321, 1.721, 2.357. I'm not going to be there to read this to you when you take your exam, but hopefully you can handle that. All right, hours is 2.82. And guys, I promise you on the exam I'll keep things, keep your data sets small. This will probably be the largest type of data set that you'll have. So I don't want you to spend a lot of time typing numbers. All right. Now always make sure you've got the same amount of numbers in each list, because if you want to get an error and drive yourself insane, have different numbers there. Different amount of measurements in a different list. You can't do quantitative analysis. It's linear regression and correlation that we're doing. You have to have the same numbers in each list. So, guys, I'm done with this. So, draw a scatter plot and see what it looks like. So, what I would do here is I would go to Window, and I would look at my axis down here. It goes from 0 to 3.5. You know, we're not going to be able to do that. Let me back up here. Let's go into stat plot, turn this on, and let's do like I've taught you. I don't want to throw you any curveballs now. All right. So we would go zoom 9, just like I showed you in the video. And now I've got something in there from a previous class I taught, not you guys. Let's get rid of that. It really doesn't matter. It's just kind of annoying. Okay. Sometimes people are like, where did you get that line? Well, that's from a class I taught about 2 weeks ago. Okay, so we know we've got a positive slope, and we just come in here and try to find which one of these looks the most like what I see on my calculator. So it looks like, the second point right here looks above the line, where this second point looks like it's below. So to me, you got to pay attention to detail here, but it looks like to me that B is going to be the best match. Does it seem that a linear trend is linear, or is there a noticeable curve? So the linear model is appropriate because we have a straight line. We don't have any non-linear relationship here because there is a linear trend in the data. Find the equation for predicting time, hours, from miles. Okay, so we're going to use our calculator here. So we'll go over to Stat, scroll over to Test, and just like I've shown you before, do linear regression t-test. Our variable x is an L1, and our variable y is an L2. This should be 1. That doesn't matter. The y1 should be there. I've shown you how to do that in a previous video, so I'm not going to do that again. And go calculate. So again, what we need is we need this A and B. Now notice A in this case is the intercept, and B is the value that goes with the x, therefore it is the slope. Okay. Now it wants us to put in the intercept first, and we need it to 2 decimal places. So I am going to go negative 0.39. And the slope I'm going to do 0.52. Interpret the slope in the context of the problem. Now guys, I put up a video not long ago and I told you the slope is for each unit increase in x, this is the change in y. So we would say for every additional 1,000 miles, the time goes up by 0.52 hours. The intercept tells us, it's easier to go back up here, when we put a 0 in for thousands of miles, it's the predicted time. So the predicted time here would be the intercept, which is negative 0.39. So, okay, a trip, okay, we have to read a little bit here. So a trip of 0 miles would take about, we know that the answer is going to be negative 0.39. However, a trip would never be exactly 0 miles, so this time might account for delays in taking off and landing. See which is more reasonable. A trip of 0 hours, where again the answer is the same here. However, a trip would never take exactly 0 hours, so these extra miles might account for when the plane taxis the runway. So guys, I am going to go with B. So again, it's negative 0.39. Use the regression line to calculate how long should it take to fly 3,000 miles. So we just need to put 3,000 in our model. But let me show you an easier way to do that on your calculator. If we go to graph now, we're going to see that things just went wacky on me. Let's see what's going on here. So I have stat L1, L2, right? Okay, cool. So I want to run the analysis. So I need L1, L2, and I need to calculate. Okay, something happened. I must not have got the L1, L2 set correctly, so guys, I've got a problem here. This slope should be 1.89, and the intercept, I'm actually glad this happened. The intercept should be 0.79. So for every 1,000 miles, this should go up 1.89. And then this will be 0.79. All right, cool. So let's put in 1,000. Let me show you something that you can do here. I'm glad I caught that. If I hit graph now after performing that analysis, notice that the line goes through the central focus of our cluster of points. What I can do now is I can go second function calc. This may be something you want to put on your cheat sheet. And go to value and type in the 3,000. And it will take me to the line, which is used for prediction, and give me, oh, yeah, I see what I did. Now remember, our x's are given in thousands of miles. So we would just put in 3 instead of 3,000. So the answer is 6 tells us to round to 2 places, so 6.47. And we can check our answer. And we missed something. Okay, let's go back and see what we may have missed. It's not going to tell us what we missed, but we can go back and probably think it through. 6.47 would never be seen, so this time might account for delays in taking off and landing. This might, when the plane taxis the runway. So I am going to change that and say 0.79 there. All right. So that's kind of a technicality on, what they takeoff and landing, taxis the runway. Okay, I guess so distance gives a time for to make the flight. So I guess maybe they're getting real technical there in terms of taxing the runway. I don't know. Okay, the accompanying dot plot shows rental prices. Use the dot plot to complete the parts below. So let's get this up, and I'm going to I'll tell you what I'm going to do. I'm going to minimize this, and I'm going to maximize this, and I'll pull this over and we'll take a look at it. So the center, which city typically has the lowest rentals? Well, we kind of look for the cluster of scores, and it looks like to me the cluster of scores here would be the lowest rents. So it looks like to me it'd be city 1. Which city has the greatest spread? Well, it looks like to me this city 3 does, because there's the greatest variation from high to low. Which direction, what is the direction of skew for city 3? So city 3 has a slight left skewed distribution. So I'm going to say done, and I'm going to bet that we get these right. Okay, the 10 top grossing movies of a certain film are given. Okay, so guys, we're going to want to put this in our calculator. So let me go back to split screen. Well, I have no idea why my calculator is quivering like that, but that's kind of funny. All right, so let's go to stat, and let's just put these numbers in L1. It's not a 2-variable problem, so we'll just do a clear enter. So I have 181, 191, 264, 194, 171, 174, 299, 283, 156, and 249. All right, so we have this in our calculator. So arrange the gross income from smallest to largest. Well, this is kind of annoying, so let me show you how you can do this on your calculator to kind of help you out. If you go stat and go sort ascending and sort L1 ascending, it will put the data from low to high. So if you run into something on your exam like this is a way that you can do that. So this is going to be a little bit annoying right here, but 156, 171, 174, 181, 191, 194, 249, 264, 283, and 299. Now find the median. I guess I wouldn't do that. I would use technology to find the median. So I would go 1 variable stats, L1. And I would scroll down to the bottom and see that the median is 192.5. Interpret the median. The median is equal to the average. It's not. 25% median is the gross income most often. It doesn't occur the most often. The median suggested 25% made it more than the median. That wouldn't be correct. So the median is the typical income, which it is. Next thing it says is find IQR, Q3, Q1 and Q3. So Q1 is 174. Q3 is 264. And the IQR is the difference. So I need to take 264 minus 174. So the IQR is 90. So guys, the IQR is the range of the middle 50%, as we've talked about before. So check your answer, and we are good. All right. Okay, the data was collected in a statistics class. The rows represent a student. How many variables? Well, there's 1, male, 2, 3, 4, 5, 6, 7, 8, 9. When writing a regression equation, which is to follow, is not a name for the x variable. Well, the independent variable and dependent variable. Guys, your dependent variable is your y variable, so that is not a name for the x. Okay, is the variable handedness? So we come over to handedness, left or right. Is it numerical or categorical? So we would say that that is categorical. Is the variable height numerical? That's in numbers, so the variable is numerical because it's numbers. It's kind of a silly question, isn't it? Okay, box plots. So we have a side-by-side box plot. It looks like we have 4 different geographical regions. So list the approximate median crimes for B, C, and D. So I'm going to make this larger so I can see it. So for B, it looks like to me that, well, this is kind of tricky, isn't it? If we come all the way down to here, I'm going to say, so the middle would be about 2,500, so I'm going to say 2,800. So we can say region A is about 24. So that's kind of weird that it doesn't have the axis. In fact, that's horrible. I don't like that. Okay, let's see if we can make this larger. So for B, it looks like to me, we're doing B. Yeah. So for B, I'm going to say that it's about 3,000. Let's go C. So C, if we follow it down, I'm going to say that's about 4,250. And for D, I'm going to go with about, so 35, that'd be 37. I'm going to go with about 3,700. I hope that the computer gives you some flexibility on that. Let's go back to view full screen. All right. List the regions from lowest to highest IQR. Well, it looks like the highest would be, IQR is the distance from of this box part. So it looks like to me it would be D, C, B, then A. D, C, B, and A. Why is the interquartile range better measure of variability for these data than the range is? What the IQR does is it lessens the effect of outliers. So the range depends on only 2 observations, while the IQR is many observations, the middle 50%, and is therefore more reliable. All right, so let's hit check answer and see if we got it right. And we didn't. Oh wow, imagine that. So where do you think we messed up? DCBA, so the IQR, I'm going with D. So the IQR, it's kind of a close one, isn't it? So let me just make it bigger and see if we can tell more about the IQR. Yeah, it still looks like to me that the IQR is DCBA. All right, so I feel pretty good about that one. I would say more than likely the median is where we're having problems. So the median for B is, gosh, is it really giving me that much problem? 30,000, 3,050 maybe. Median for C is, I'm not willing to go off 4,250 on that one. The median for D, so that's going to be 3,750, 3,700. From, oh shoot guys, what did I do? It says lowest to highest IQR. So I got that completely backwards. This should be A, this should be B. You guys are probably sitting there screaming at me on that just because I didn't read. All right, well I guess that's a good thing about having 2 attempts. Even when you do something like when you know what you're doing, you just do something that's a bozo thing like I just did. You've got another opportunity to find it. All right guys, match the distribution with the correct histogram. Well, you know that rolling a fair die, so it's going to be, your 6 outcomes is going to be approximately the same. So I know that C goes to A. So I'm down, I'm sorry, 3 goes to A. So I need to come down here and find 3 to A, and 3 only goes to A in one of those. So I'm good with the rest. So a blank is a tool for making predictions about future observed values and is a useful way of summarizing. Well, we're looking for a linear regression model. So let's go with the regression equation. So baby's born weighing 2,500 grams or less are called low birth. The mean for weight of a certain country is 3416. So both standard deviations are 480. Find the standard score. So let me go to view. So the first one for 2,500 for all births in this 2,500. So the mean is about 1 month early. Okay, so this is kind of confusing. So it's 3416. So I need to find the z-score for the 2,500. So I take the observation minus the mean, which is 3416, and divide that by the standard deviation, which is 480. So this is negative 1.91. Find the standardized score for using 2,600, 2660. Okay, I see what's going on. So I'm going to need to bring the same entry down. And really all I need to do there is just change the mean from 3416 to 2660. Or just retype it again, however you. So it would be negative 0.3 0.33. Now, for which group is a birth weight more common? Well, it's going to be the one that's closer to the mean, so that's going to be for the child born 1 month early. So it looks like to me that B is going to be the correct answer. Okay, would it make sense to find the correlation with this data set? Yes, because it has a linear trend. Choose the correct answer. Would it be positive? Clearly positive. Okay, we have a dot plot. What is the z-score for a height of 55 inches? So I want 55 minus the mean, which it says is 64, and divide by the standard deviation, which is 3. So guys, the z-score would be -3. What is the height of a woman with a z-score of 1? Well, a 1 is going to be 1 standard deviation above the mean, so all I have to do is add the standard deviation to the mean and get 67 inches. One important use of the regression line is to do what? To make predictions. Okay, what city tends to be the warmest? Well, the warmest would be with the median with the highest value. So I'm going to go with city F. Okay, it gives me 2 choices. So E and F, A and F. Okay, so I want the 2 highest medians, the way that this is provided, you know, the way the context that the question is provided. So the 2 highest would be the ones with the 2 highest medians, so that would be A and F. City blank has the most variation. Well, we want the one with the biggest spread, so I'm going to go with city E. And which has the least variation? Well, I'm going to go with the squattiest one, which with little variation. So well, actually it has me doing 2 of those, so it looks like this one, and so D and F should be the right answer. In statistics, the data we work with just one part of the bigger picture called the population. Remember, we typically in in statistics, the goal is to take a sample, a random sample, and use it to make an estimate of a characteristic from a larger population. Okay, since in general, the longer a car is owned, the more miles it travels, one can say there is probably a positive or negative between age and car mileage. Well, guys, when you get in a situation where as one variable goes up, the other one tends to be higher, that's different than if one goes up, the other tends to be lower. Well, when both of them go up, you've got a positive trend, a positive association. An example of something that would have a negative association kind of in the same context would be maybe the weight of a car in miles per gallon, because you would think a heavier car would get less miles per gallon, like a Hummer. You would think that it would get less miles per gallon as compared to a smaller car. The accompanying scatter plot, so we get this. Now, guys, I look at that and I see major problems. And the major problems is, it looks like to me they fit a linear model to this relationship, but this relationship isn't linear. We have a curved, a non-linear relationship here. So what they did there is an error. So I would come down here, I'm looking for not appropriate. And it's not appropriate because we have a non-linear relationship, an association, or a curved trend. Another name for a regression line, it can be a lot of things. Line of best fit, that a lot of people call it least squares. That's kind of the underlying statistical property, if you will, that or technique, not property, a technique that that drives the whole calculation of the line of best fit. You try to minimize what's called the sum of squares. All right, gang. There are how many observations? Well, it looks like to me there are 4 observations. Remember, the number of people in your number of people, objects, subjects, trees, cats, dogs, whatever it may be. You can find out the number of people in your study by reading left to right. So we have 4 lines. The number of the number of variables we read up and down. So there'll be 4. So we know that's going to be right. We're moving right along now. If the mean and the median of a distribution are approximately, this thing's losing its mind again, so let's get rid of it. All right, if the mean and median are approximately the same, then we have a symmetric distribution. Now guys, remember, in a positively skewed or a right skewed distribution, the mean will be bigger than the median. In a left skewed, a negatively skewed distribution, the mean will be less than the median. And the reason is I've explained that in previous problems or previous videos. All right, guys, what I would want to do here is let's go part screen. Let's bring up presenter again. Hopefully it's not jumping around like it's insane. All right, I want to now what I want to do here is I want to get this information in my calculator. So again, let's clear that out and go clear enter. So 4.9, 4.7, 4.2, 4.1, 3.9, and 3.7. And over here we have 3.8, 2.9, 3.3, 2.6, and 2 1.9s. Now what we want to do is we want to calculate the correlation coefficients. So gang, I'm just going to do it like we've done it before. Make sure I've got L1, L2. Come all the way to the bottom and find R, and it's 0.86. Well, it says 3 decimal places, so we need to do 0.856. Comment on the meaning of correlation. Now what happens since we got a positive correlation? It tells us as one goes up, the other goes up. So as the quality of the professor goes up, the easiness scale goes up. So the professors that have high easiness have low quality. Well, that's not true. Being easy as a professor causes, guys, anytime you see that word cause in a statistics problem, you can immediately get rid of it. We don't do cause and effect with regression. There are things in statistics there are techniques in statistics we can use to model causation. This is not it. Professors that have high easiness tend to have high quality. So as one goes up, the other goes up. So guys, I am going with those. And that's going to be right. Statistics often write the word blank in front of the y variable. Well, we're doing a predicted variable. So we check the answer and it's going to be right. Now, why do we say predicted? Let's go back over here and let's just do zoom 9. And so when I have an x value, I come over to the x value on the x-axis and I go up to that line to predict using these other observations that we've collected and that have been used to create this line. We go up and use this as a prediction. It's not the y value, like right here. If I happen to choose the same x that's on that point right there, this point's above. This y value is above the predicted value. This y value is above the predicted value. This y value is below what the predicted value would be for that particular x. So it's a predicted value that we're focusing on with the equation of the regression line. All right, on the basis of the scatter plot, well, guys, that's clearly a positive trend. So if you get one of those, smile real big, because that's going to be an easy one. Okay, at their inauguration, the ages of the ages of the first 6 presidents. So, guys, I'm going to go over here and I'm going to clear this out. And I'm going to type these numbers in. So I have 56. 63, 60, 58. I love small data sets like this because it doesn't take long to enter the numbers. So the first thing we want is we want the mean. So I'm going to go ahead and just do calculate, and I put everything in O1, so let's go there. So the mean here is 59. Round to the nearest tenth, so I guess that means that it wants us to do 0.0. The mean of the most recent 6 presidents is 61, so the first 6 presidents tended to be a little younger than the most recent 6 presidents. I don't know if it includes Obama. I guess relatively speaking, he would be a younger president, so... but the first 6 presidents tended to be actually a little younger because the mean is less than... Okay, interesting. Find the standard deviation. Well, guys, standard deviation is always SX, so 3.6. I mean, we need nearest tenth, so 3.7 years. So the standard deviation of the most recent 6 is 10.3. So do the first, they have less variation because the standard deviation is less. All right, guys, we've got a curve there. So linear regression is not appropriate. Here we have a linear trend, so it is appropriate. Large number of data points has nothing to do with it, at least at this stage. It plays a role in some of the stuff that we do, like dealing with power and things like that, but not really appropriate for this class. All right, gang, we're about to wrap this up. We have, I think, about 8 more questions. The mean response, the mean represents the typical value in a set of data for what type of distribution? Well, guys, if we have a roughly symmetric distribution, we want to report and depend on the mean. If we have a skewed distribution, we want to report and depend on the median. So you've kind of heard that ad nauseum now, so it's going to be something that you're pretty good at. In a right skewed distribution, well, guys, we want the mean here. I'm sorry, we want the median here. Because the mean will be pulled toward those outliers that cause the distribution to be right skewed to begin with. So, so the mean will be higher than the median in a right skewed distribution. It will be less than the median in a left skewed distribution. When a distribution contains outliers, what's the best measure of center? Well, we just talked about that. It's the median because it's the most stable. And again, I put up about a 30-minute video just on that very topic. So, all right, the scatter plot shows the relationship between men and women. Okay, that's interesting. So we have the regression equation. All right, so find a rough estimate of the median pay for women in a city that has a median pay of $60,000 for men. So when I come to $60,000, I come up here, I can visualize that regression line going about right through here. So 60,000, I'm going to say, is somewhere around 45,000. So it looks like to me the one that would be about 45,000 would be between 40 and 50,000. Using the given regression equation and get a more precise estimate. So now we can put the 60,000 in our regression equation. Well, I'm going to have to get that fixed. That jumping around is kind of crazy. So I want 8188 plus 0.6082 times 60,000 to get the estimate. So 44,680 would be the approximation there. All right, gang, getting close. All right, match the correlations. So we know that this one's negative. C is negative, so we know that that's going to be the negative correlation. And the correlation for B is going to be much higher. The correlation for this back here, A, this is going to be close to 0. So we want to choose the smallest correlation there, and it would be 0.069. And this has a positive trend, so we want a positive correlation. So very confident that this one's going to be right. Okay, the study of statistics is based on what two major concepts? Well, that's going to be variation and data. Told you that one in 2 videos. If you're not watching the videos, it's going to come back and haunt you when you take your exam. What are 2 commonly used graphs to represent a display distribution of categorical? Again, I gave that to you earlier. It's a pie chart and a bar chart. Typically for quantitative, we use a histogram and dot plots, or histogram in a box and whiskers or box plot. Attempting to use the regression equation to make predictions beyond the range of data is called extrapolation. Talked about that in a video. It's funny how everything I taught you earlier is coming full circle. Alright, it's a correlation between height and weight. 0.64. Find the coefficient. Well, apparently that's just wanting to pop up. Find the coefficient of determination and explain what it means. Alright, so we know that R is 0.64. So if I go over here, I need to take 0.64 and square it to get the coefficient of determination. So it's going to be 0.4096, and we report that as a percentage, so it's going to be 40.96%. We don't need the calculator anymore, so I can go to this. So it's 40.96%. Therefore, the variation, notice it gives you everything the same except for weight and height. So we explain the variation in the y variable. So height is the predictor and weight is the response. So in the way they've set this up, weight is the y value. So this coefficient of determination explains the variation in the y variable. So guys, correct answer is going to be B. So we did well, except for a little mix-up in getting me having a bonehead moment and reading a question wrong, thinking it was largest to smallest and not smallest to largest. We did pretty well. So, guys, that's all I got. Hope this helped. Take care.